Hello, this is going to be a video talking about pH, and you've heard about pH before, and we're going to talk about it very generally and briefly and how to go about doing some very simple calculations. pH is a measure of the acidity of a solution, or you can think of it as a measure of the alkalinity from the other direction, how basic a solution is. And most folks know that pH less than 7 gives you an acidic solution, and a pH greater than 7 is a basic or alkaline solution. And at 25 degrees C, if you happen to be at pH 7, you're neutral. So pH is defined as minus the log of the H plus concentration, or minus the log of the hydronium ion concentration. A little bit later in your chemistry career, you might actually talk about activities, in which case it's minus actually the log of the activity of the hydronium ion concentration. But that's just a little caveat for now. Forget I even said that. But minus log of the hydronium ion concentration. So it's important to learn how to use your calculator to do this. So let's just do some simple pH calculations. But as we do so, I want to start in on what a logarithm looks like. It really has two parts to it. There's something that's called a characteristic and something that's called the mantissa. And it's the mantissa that's going to come into play when we talk about significant figures. And that in a logarithmic world, now we're moved out of base 10, or regular decimal world, into a logarithmic world, the number of decimal places equals the number of significant figures in a logarithmic number. And so don't let that throw you off. Typically, we're going to have 2 decimal places in a pH. Because that's the best precision typically that we can get with a pH meter. Let's do some calculations. Let's take a solution that's 8.5 times 10 to the minus 5 molar HCl. Now, the calculations we're going to be doing are for strong acids. What you really need to go through when you're calculating pH is ask yourself the question: is it acid or base, weak or strong? Because in subsequent chemistry courses, which it is, be it weak or strong determines which pathway you take in terms of doing the calculation. And that weak acids and bases will have a more complicated solution than what we will be doing here. And we will be doing nothing but strong acids, but if you get in that mindset of asking yourself, acid or base, weak or strong, that'll benefit you down the road. So 8.5 times 10 to the minus 5 molar HCl, strong acid. And so if you show how it reacts with water, it dissociates 100% to make hydronium ion and chloride ion. And so 1 mole of HCl produces 1 mole of hydronium ion. And so let's do this calculation, and that pH is equal to minus the log of the hydronium ion concentration. So pH is minus the log of 8.5 times 10 to the minus 5. And this is where being able to use your calculator correctly comes into play. So you need to familiarize yourself with your calculator and the markings that are on the buttons. My calculator has a button that says log. And so, and how you enter the numbers in particular order will be peculiar to each type of calculator. So make sure you understand how to do this with your calculator. So the way my calculator works, I'm going to put in 8.5, exponent, change sign, 5, and then I hit the log button. And what I will see in my calculator is minus 4.07. Now, the definition of pH is minus the log of whatever number. So it's going to be a minus 4.07, or simply 4.07. This doesn't have 3 sig figs. It's really only got 2 because it's a logarithmic number. The number of decimal places in the mantissa past the decimal has to equal the number of sig figs in your original concentration. Let's do a 6.4 times 10 to the minus 3 molar solution of HCl. Acid or base? Acid. Weak or strong? Strong. And so pH is going to equal minus the log of 6.4 times 10 to the minus 3. So in my calculator, put 6.4, exponent, change sign, 3, hit the log button, and I will see minus 2.19. That's the number. This is the log of 6.4 times 10 to the minus 3. But it's going to be a minus 2.19, so it's going to be 2.19. Let's do 1.0 times 10 to the 3 molar hydrochloric acid. Acid or base? Acid. Weak or strong? Strong. And all these calculations are only valid for strong acids that we're doing. So pH is minus the log of 1.0 times 10 to the minus 3. So there are 2 ways to go about doing this. You put in 1.0, exponent, change sign, 3, take the log of that, and you'll see in your calculator minus 3.00. The minus and minus will make that a positive, so 3.00. The other way of doing this is if you recognize the log of 1 is equal to 0. And so when you're doing multiplication and doing logs together, you add the logs. And so we're going to add the log of 0 plus the log of 10 to the minus 3. And so logarithms refer to what that exponent is for the power of 10. And so the log of 10 to the minus 3 is simply 3. So log of 1 is 0 plus the log of 10 to the minus 3 is minus 3. So you get minus 3. And so if you've got 1.0 times, and even 1.0 times 10 to raise to some power, it's just that power that becomes the pH when you take the negative of that. Let's do this solution. 1.0 molar hydrochloric acid. Weak or strong? It's a strong acid. So pH is equal to minus the log of the concentration. And so the log of 1 we just said was 0. So the pH of this solution is simply 0.00. 2 decimal places refer to the 2 significant figures I have in my solution concentrate starting out. So don't let this fret you. You probably somewhere along the way thought that pHs range from 1 to 14. Well, they don't. They can be higher than 14 or they can be less than 1. If you've got a really concentrated acid solution, it can be less than 1. this really concentrated base, it can be greater than 14. So don't let that fret you. So let's do this one actually. Let's do a 12.0 molar solution of hydrochloric acid. This is as concentrated a solution of hydrochloric acid that you can find. So minus the log of 12.0. So this will be a minus 1.079 is what I see in my calculator. And now you do this answer and you wind up with a negative pH actually of minus 1.079. Remember, my 3 decimal places here correspond to my 3 significant figures in the concentration that I started out with. So pH isn't always between 1 and 14. What if we want to go the other way? What if we have a high pH and we want to calculate the hydronium ion concentration? So if pH is minus the log of the hydronium ion concentration, the hydronium ion concentration is equal to 10 to the minus pH. So if I have a solution that has a pH equals to 3, the hydronium ion concentration is equal to 10 to the minus 3.00, which is going to equal to 1.0 times 10 to the minus 3. Once again, I've got 2 decimal places in my mantissa. That means I'm only going to have 2 decimal places in my concentration. So the way I entered it in my particular calculator is I actually put in 3, change the sign, then do inverse log. And I wind up with 1.0 times 10 to the minus 3. Your calculator, the way you enter the numbers in particular order may be different, so make sure that you learn how to do that. Let's do pH of 5.62. The H plus concentration, or the hydronium ion concentration, is going to equal to 10 to the minus 5.62. So I'm putting in 5.62 into my calculator, changing the sign, and doing inverse log. And I wind up with 2.4 times 10 to the minus 6 molar. Oops, I should have had a molar for my concentration up in the first one. So that's what my hydronium ion concentration is. How about a pH of 6.23? The hydronium ion concentration, or the H plus concentration, is equal to 10 to the minus 6.23. And that'll give me an answer of 5.9 times 10 to the minus 7th molar. And let's do a basic solution. Let's do pH of 8.91. So the hydronium ion concentration is equal to 10 to the minus 8.91. And that'll equal to 1.2 times 10 to the minus 9 molar. So that's a little bit about calculating pH and then calculating the hydronium ion concentration from the pH. Once again, this has been for strong acids. When you do weak acids and bases, in general, you may be doing something a little bit different in these calculations when going from the concentration to the pH. Thanks for watching.